My name is William Drake, and this is my video about machine learning. So I'm going to be talking about integration and application of supervised learning, unsupervised learning, and reinforcement learning in tomato leaf crop detection as my project. So supervised, unsupervised, and reinforcement are the three types of machine learning, and I'm going to show you how I've used supervised, unsupervised, and reinforcement learning in my project. So we found I found a problem that farmers could not easily detect leaf blight. Most times they couldn't differentiate between leaf blight with other diseases affecting these leaves. So I came up with that idea to help these farmers detect leaf blight. There are many machine learning projects that have been made, but I've also decided to use my knowledge to carry out this project. So the first thing I'm gonna do is I'm gonna explain what machine learning is, but this is just a branch of artificial intelligence that enables machine learn from a given set of data, like to make future predictions and improve on certain human activities. So this involves training algorithms on a large set of data, let us say images on affected and healthy leaves, to make patterns and make predictions or classifications. So in the context of tomato leaf blight detection, machine learning algorithms, particularly deep learning, have been used to detect with high accuracy. Other thing is, okay, the significance of the project, as I've already told you, like farmers are only using like their naked eyes to detect like whether it's leaf blight or any other disease, hence less accuracy. Yet if we use machines or like machine learning algorithms, these can effectively detect this leaf blight, and it can detect at a rate of 95%. That is the accuracy. So we have supervised learning, unsupervised, and reinforcement. With supervised, we are going to use labeled data to supervise these machines to learn. So we give it input and output, like to compare with to teach these machines. So next time when we provide them with a certain either image or anything to be able to detect or make predictions. With unsupervised learning, it's a type of learning method in which a machine is trained on unlabeled data without any guidance. So this data is not labeled, just give it, and then it makes clusters, or it makes clusters. With the reinforcement method, so in this type of method, there's an agent which interacts with an environment using actions, and later it's given a reward. If it does something different from what is expected, it's given a penalty. And if it does something that is expected, it's given a reward. So we have different types of supervised learning. Supervised learning, we have regression and classification. In a supervised learning, we have association and clustering. So as I've already said, supervised, we use labeled data. Unsupervised, we use unlabeled data. And then for reinforcement, we don't have any predefined data. It's just a set of actions. So supervised learning needs external supervision. Unsupervised, we don't need external supervision. And then reinforcement, there's no supervision. So supervised learning is mainly used to forecast outcomes. Unsupervised used to discover underlying patterns, and reinforcement used like to learn series of actions. So the machine or agent will learn different actions to be taken different actions, and then it will either be given a penalty or a reward. So supervised learning have direct feedback. Unsupervised, there's no feedback. And then reinforcement works on a reward system. Then supervised learning have different algorithms such as linear regression, logistic regression, support vector machine. Then in unsupervised, we have k-means, we have a priori c-means, and in reinforcement, we have k-learning. So I'm going to go into details. I've already talked about supervised learning. So you're training model and labeled data where each input is associated to a corresponding output. As you can see, we have labeled data, that is carrots, tomato, and bell pepper. So training, we are using this data to train this model training so that it can make predictions. So after training, we provide it with a test data, then to tell us like the expected outcomes. Then different types, we have classification, then we have regression. With classification, you're just going to categorize different sets of data together. So you're grouping predicting categories to different outputs based on the input data. Then with regression, it is used to predict real or continuous values where they're going to take relationship between two or more variables. For an example, it's predicting salary based on work experience. Then, so different types that we have used random forest in our project. So as you can see, so we start with a decision node, then go on to other decision nodes like comparing. So random forest is a versatile and accurate supervising learning algorithms that can be applied to tomato leaf blight detection. It has an ability to handle large data set. Then we can go to decision trees. This can also be used. So by creating a tree-like model of decision, these algorithms can effectively differentiate between healthy and diseased leaves based on features such as color, texture, and shape. Then we can use naive bias, that is probability. So naive bias classifiers can be applied to tomato leaf detection by utilizing probabilistic models to determine the likelihood of having a disease feature or not. Then we can use support vector machines. So some of the classification problems, we have identifying different types of tomato leaf blight, classifying tomato leaves as healthy or diseased, then regression, that's predicting the severity of tomato leaf blight based on environmental factors. So how often can it happen in this kind of temperature, humidity, or rainfall? Because blight is always highest in rainy seasons, then highest when the temperatures are really low. So we can use this regression to know when it happens highest or when it happens lowest. Then we can use regression to forecast the spread of tomato leaf blight in particular regions. Then labeled data, as you know, we have to use labeled data. That is, we can use a picture of unaffected and a picture of a healthy leaf to train these supervised models. Then with unsupervised, I've already said, we have to use like unlabeled data. So we give it all the data. So it will use its own algorithms without any supervision to group different outputs together. So making clusters or associations. So we have clustering and association. With clustering, we are grouping different data together. Then with associations, we want to find like insights or relationship between different kinds of data. Then, so clustering can be used to group similar tomato leaves images together. Then with association, to identify relationship between different features of tomato leaves, such as color, texture, and shape, and the presence of blight or other diseases. So insights, you have clustering, group similar data, then association. Yes, identify relationship between different visual features of tomatoes, as already talked about it. Then handling data. So this is unlabeled data. So you're gonna use clustering and association to group the data together. Then reinforcement. So it trains software to make decisions to achieve the most optimal results. So using an like erroring method. That is, if you make an error, you're given a penalty. If you do something right, you're given a reward. So we use that. So the agent is interacting with an environment with getting a reward. So there's an action to the environment, then it's given a reward thereafter. So that is it. So we have the environment, we have the agent, and then the reward based on the action. So potential scenarios. So early, we are gonna use machine learning in early disease detection, automated disease monitoring, then improved crop yields. Then there's optimization of disease management strategies using like k-means clustering. So farmers can develop more effective disease managing strategies such as using disease-resistant tomato varieties or applying appropriate treatments at the right time. Then we have like comparative, we've already compared these at first. So with supervised, we're gonna use labeled data. With unsupervised, we're gonna use unlabeled data. Then reinforcement. So we're just gonna use optimization decision-making processes. So I think that's all I have. All these are just repetitions. These are just repetitions. Then we have the challenges. We have the data quality challenge. So we can have inaccurate data, unlabeled data. So these can all cause problems. Then computational resources, like due to poverty, you cannot have like the real machines which can help us. Then the more strong machines can help us. Then all other problems. Then the bias in data. So the ethical biases, we have bias in training data, we have interpretable biases, informed consent and transparency, then security privacies. Because of limited time, I have to go through. So majorly, you're gonna use the convolutional networks, which can actually classify and identify specific diseases on labeled data. So the unsupervised learning techniques we can use, they are the k-means clustering, which can identify patterns in the diseases, then reinforcement and optimize detection and treatment of diseases. So that's my presentation.